The age of the universe. Are we wrong about time? Music fades in. Ethereal, cinematic tone. Narrator. Just over a century ago, our understanding of the universe was surprisingly limited. Many astronomers believed that everything, stars, planets, and galaxies, was confined within the Milky Way. The idea that the universe extended beyond our galaxy was almost unimaginable. That changed in 1928, when astronomer Edwin Hubble made a groundbreaking discovery. By observing distant galaxies, he found they were moving away from us, and the farther they were, the faster they receded. The universe wasn't static, it was expanding. This single insight revolutionized cosmology. Fast forward to 1997, when the Hubble Space Telescope revealed another surprise. The universe's expansion wasn't slowing due to gravity, it was accelerating, powered by a mysterious force we now call dark energy. This discovery helped refine the universe's estimated age to 13.8 billion years. But new evidence suggests that number may not be as solid as we once believed. The puzzle of M92 deep within the Milky Way lies an ancient globular cluster called M92. It contains some of the oldest stars ever observed, so old, in fact, that they appear nearly as old as the universe itself. And some models suggest they might even be older. But how can that be? By definition, nothing can predate the universe. Yet using advanced simulations, over 20,000 synthetic star populations, astronomers calculated M92's age. And the result was startling, nearly 13.8 billion years. With margins of error that leave room for something even more troubling, a cluster potentially older than the universe. This paradox forces us to ask, have we been wrong about the universe's timeline? The James Webb revelation launched in 2021, the James Webb Space Telescope, JWST, has taken us further back in time than ever before. Using infrared vision, Webb peers through cosmic dust to observe the universe's infancy. And what it's found is raising even more questions. Webb has identified massive, well-formed galaxies that existed just 300 million years after the Big Bang. According to current models, that's far too soon. Galaxies that evolved this quickly simply shouldn't exist, at least not yet. So how did these colossal structures form so early? Could our understanding of cosmic evolution be incomplete? Or could the universe itself be much older than we think? A radical proposal. 26.7 billion years. In light of these contradictions, some scientists are rethinking everything. A new theory proposes that the universe may not be 13.8 billion years old, but closer to 26.7 billion. This model reinterprets how we measure redshift and cosmic expansion, the tools we use to calculate age and distance. It challenges the assumptions baked into our current models and suggests that early galaxies had more time to evolve. If true, the universe could be nearly twice as old as we thought. The Methuselah star mystery. Another puzzle comes from a nearby star called HD 140283, also known as the Methuselah star. It lies just 190 light-years from Earth, and appears to be about 14.5 billion years old. That's almost a billion years older than the universe itself, based on current estimates. How is that possible? Stars follow predictable life cycles. But Methuselah seems to defy that logic, aging more slowly than expected, or existing in a timeline we don't yet Rethinking the universe. The evidence builds, music fades in. Mysterious, steady rhythm, narrator. We questioned one of science's most sacred numbers, the age of the universe. Could it really be 13.8 billion years old, or have we misunderstood cosmic time altogether? From the ancient star cluster M92 to galaxies forming too early, the evidence keeps building. Now, we dive deeper, into the tensions, theories, and forces reshaping our view of the cosmos. The Hubble tension. A universe divided at the center of the age debate is a crucial value. The Hubble constant. The rate at which the universe expands. But there's a problem. Two of our most trusted methods give different answers. Early universe data, from the cosmic microwave background, suggests a value of about 68 km per second, MPC. Nearby measurements, from galaxies and supernovae, suggest a faster expansion, around 73 km per second, mpc. This disagreement is called the Hubble tension, and it's not a minor error. It reveals a deeper issue. If we can't agree on how fast the universe is expanding, how can we be certain of its age? Galaxies growing too fast. The James Webb Space Telescope has revealed fully formed galaxies just 300 million years after the Big Bang. Massive, complex, too evolved for their supposed age. According to standard models, galaxies shouldn't form this quickly. One possible explanation? Primordial black holes. These ancient objects may have formed just seconds after the Big Bang, serving as gravitational seeds that helped galaxies build mass faster than expected. It's a bold idea, but one that could explain why we're seeing the cosmic timeline out of order. Dark energy, constant, or changing? We once thought dark energy, the mysterious force accelerating the universe's expansion, was constant. But new data suggests it might be changing over time. If dark energy has evolved, it could explain the rapid expansion, the early galaxy growth, and even the discrepancies in the Hubble constant. It would also mean our timeline is based on unstable foundations, and must be revised. When time breaks down at the quantum level, time doesn't behave the way we experience it. Tiny fluctuations, strange behaviors, moments where cause and effect may blur. In the earliest instance of the universe, time itself may have flowed differently, or not at all. This raises a stunning possibility. What we see as inconsistencies in age or structure might be echoes of a quantum beginning, a moment when time, space, and energy were in flux. A multiverse, or cycles without end? To make sense of it all, some scientists look beyond the known universe. What if we're in a multiverse, one of many universes, each with different rules and timelines? Or what if our universe doesn't have a beginning and end, but follows a cyclic pattern, with expansion and collapse repeating infinitely? In that case, ancient galaxies and stars might not be anomalies at all, but leftovers from a previous cycle. These aren't fringe ideas anymore. They're serious theories gaining attention as the data defies explanation. A new age of discovery with every image it sends back. The James Webb Telescope is telling us a new story. One filled with contradiction, beauty, and possibility. Stars that may be older than the universe, galaxies that formed too soon, a universe whose expansion is still not fully understood. We're no longer just updating numbers. We're rewriting the narrative of our entire cosmic history. Conclusion. A universe beyond belief. So what if the universe isn't 13.8 billion years old? What if it's 26.7 billion, or eternal? What if time doesn't flow the way we thought, or the Big Bang wasn't the beginning? These aren't just abstract questions, they shape how we understand everything: matter, life, and our place in existence. The universe may be older, stranger, and more infinite than we ever imagined. But one thing is certain. With James Webb as our guide, the frontier of discovery is just